We have seen elsewhere solutions that the oceans can provide for climate change. Of course, oceans absorb more than 93% of the additional energy that's being trapped because of increased greenhouse gases from human activities. But in addition, we looked at carbon dioxide removal potential and so on. And I wanted to revisit this in the context of some new reports. This is, of course, the Sustainable Development Goal 14, which talks about life below water. Conserve and sustainably use the oceans, sea and marine resources for sustainable development. Our ocean, the planet's largest ecosystem, is endangered. Plastic marine pollution, of course, is a huge problem. There is ocean warming, which is going deeper and deeper. Eutrophication, which is all the nutrient runoff from land, agriculture, urbanization and deforestation, and so on. Acidification, increased CO2 in the atmosphere directly begins to reduce pH of the ocean, even though there are details about what its impacts are and what they could be. So I have a separate podcast on whether there are many species which are doing fine and what will be the worst case scenario for 2100, for example. And overfishing and loss of fisheries and reductions in fisheries yields are a big problem, of course. Increasing acidification comes up very often now, and it is threatening marine life and limiting the ocean's capacity to moderate climate change in terms of its ability to take up more CO2 as we keep increasing the CO2 in the atmosphere. So the ocean absorbs around 1/4 of the global annual CO2 emissions. So obviously it's an important sink, and if it begins to warm and solubility begins to decrease and winds change and overall acidification also begins to reduce the ocean sink, then we'll be in trouble, accelerating the warming, of course. Plastic pollution is choking the ocean. 17 plus million metric tons of plastic entered the ocean in 2021. It is projected to double or triple by 2040. There are many efforts now to remove plastic from the oceans, of course, sweep it up, but it's found at the bottom, in fish, in humans, in all systems around the world, so we have to be careful. And 90% of the world's fisheries are employed in small-scale fishers. 90% of the world's fishers are employed in small-scale fisheries who need accelerated support due to the pandemic. So the COVID years 2020 and 2021 ended up causing a lot of damage for a lot of poor people, and even the recovery has not been even because rich countries could print money and provide stimulus funds, whereas poor countries cannot simply print money without crashing their currencies, right? So this is always tricky. This is a paper that provides an estimated cost of implementing SDG14 targets by 2030. Any estimates, economic especially, include a lot of assumptions, a lot of modeling, a lot of players and rules and so on, but it's worth looking at, especially because we also get a sense of the details of the SDG14 targets. So reducing marine pollution, the biodiversity targets under HE target 8 pollutions, resources needed 87.3 billion, range of uncertainty is provided as medium to high. So obviously they are very honest in estimating the uncertainty as well. 14.2 looks at protect and restore ecosystems. So this will cost estimated 34.1 billion by 2030 with a medium uncertainty. Reducing ocean acidification, overlap with resources needed for SDG 13 and 14A, which I won't go into here. 28.4 billion, so that's on acidification. Uncertainty here is high. Sustainable fishing, 5.9 billion, medium to high uncertainty. And subsidies, every fish we eat now is heavily subsidized, so we underestimate the impact of these subsidies, including there are many that are directed at fossil fuels, including tax rebates for fossil fuel companies and so on. So resources added of US $20 billion here. Increase economic benefits to SIDS and low developing countries and something island state developing states. So please look that up. Sorry for muddling this. Okay, so this overlaps with resources needed for SDG 14.4. Increase scientific knowledge, research at small island developing states here. Okay, increasing scientific knowledge, research and technology for ocean health, not accounted for in the study. Support small-scale fisheries, not accounted. Implement and enforce international law of the sea, not accounted. So total cost here of $155.5 billion to implement SDG 14 by 2030 with medium to high uncertainties. There is an effort to bring high impact investments into sustainable oceans, and this from the World Economic Forum provides a map of the revenues in US dollar billions, and the company ranks here, and they include various number of companies covering offshore oil and gas, seafood, shipbuilding and repair, port activities, offshore wind, cruise tourism, container shipping, and marine equipment and construction. And the countries which are making most of the money or companies include things like Saudi Aramco, Petrobras, National Iranian Oil Company, you have Hyundai Heavy Industries here, Evergreen Marine Corporations here, and at 100 here, Trident Seafoods. Obviously, I'm not going to read all of these, but you can see if you add up these numbers of the companies that are directly and indirectly making money out of the ocean and ocean resources, then that's a huge amount. And there are companies which are trying to find solutions. So this is a private effort now trying to grow seaweeds on large scale in the open ocean. This is an experiment to see if they can keep the seaweed contained so that they can increase the reproduction, retention, and significant amount of drawdown at a place where ocean is likely to take the CO2 down from the photosynthesis. But they also have designs to consider that. So capturing carbon using seaweed, sargassum seaweed absorbs CO2 from the atmosphere. We've talked about coastal ecosystems like mangroves, for example, being able to take up 3 to 10 times the land forests, and they don't burn down. They improve habitats with oxygen being released into the water, and they act as barriers to storms, reduce erosion, and so on and so forth. But this is an open ocean ecosystem, intentionally growing ocean forests like seaweeds, which obviously with photosynthesis and fast growing seaweeds can take up a significant amount of CO2. Then they design pipes drawing down nutrients from the deeper ocean. So there is some artificial pressure gradient and circulation set up so that solubility pump brings up the nutrients, and the biological pump can take down the CO2. So seaweed containing captured carbon is sunk to the ocean floor. You can see that here. So this is an accelerated, amplified biological pump which occurs in natural oceans as well. But this is potentially happening in a place where nutrients are not available in the euphoric zone. You bring them up, you feed the ocean forest, and you create additional CO2 sinks and put it out to the bottom beyond the solution depths at which CO2 can be stored for a longer time. So this is a schematic of the South Atlantic carbon capturing seaweed farm, and this is of course in the subtropical gyre with the circulation which is converging. Typically that means downwelling, lack of nutrients. These are the ocean's deserts. So you are going there and pumping up nutrients artificially and creating forests in the desert. So seaweed farm of 169 mile wide in the South Atlantic gyre, the subtropical gyre. Plan is rotating ocean currents will hold seaweed in place because these are converging currents and downwelling currents. Things congregate here, including plastic pollution, for example. So there are efforts like this. A mission 1000 ocean startups is a coalition to accelerate ocean impact innovation. So how to fund innovations that help ocean be sustainable, continue to take up CO2, reduce acidification, and so on. The coalition brings together the global ecosystem of incubators, accelerators, competitions, matching platforms, and venture capitalists supporting startups for the ocean impact. Our objective is to scale at least 1,000 transformative startups by the end of the ocean decade to restore ocean health and achieve SDG14. We achieve our objectives through building synergies between ecosystem participants and telling the story of success already achieved and the potential of innovation to regenerate ocean health, to inspire investment in scaling now the ocean impact innovation system. As the coalition works to achieve its mission, it responds to the transformations recommended by the Ocean Panel. The coalition is a founding member and implementation partner of GEO's UN Decade program, which is being run out of Georgia Tech with lots of consortium partners, and I think I'm still on the International Steering Committee for GEOS. There is the other Planet Tracker, which is a non-profit financial think tank producing analytics and reports to align capital markets with planetary boundaries. We have discussed planetary boundaries elsewhere, where we look at the limits of certain human perturbations like the nitrogen cycle, deforestation, biodiversity loss, fisheries, and so on, to see how we can stay within those dangerous boundaries. Our mission is to create significant irreversible transformation of global financial activities by 2030. 2030 remains a very strong timeline by which we have to find ways to turn events around and start bending the curve on pollution and its impacts. By informing, enabling, and mobilizing the transformative power of capital markets, we aim to deliver a financial system that's fully aligned with a net zero, net positive economy. So instead of being extractive, we begin to become net positive. Planet Tracker proactively engages with financial institutions to drive in their investment strategies. We ensure that they know exactly what risk is built into their investment and identify opportunities for funding the system transformations we advocate. So, good time to get into some of these activities and help the accomplishments that are needed to achieve the goals of Sustainable Development Goal 14 on sustainably using and exploiting the ocean and reducing human impacts in terms of acidification, ocean warming, and the associated impacts. Okay.